Today we'll continue from where we stopped last video. If you haven't watched it yet, go check it out and then go back here. And what we'll learn today is how to make our car accelerate, which means make it go forward and backward, and also add the debug lines that will help us to understand better what our car is doing. So let's get started. The first thing we're gonna do is to install the plugin called debug 3D, and you can find it at the Asset Lib tab up here. Just search for debug and install it. We can ignore those errors for now and also delete this folder here. Now let's go to the car script and add a new variable called debug. It has type boolean, and let's set the default value to false. That will create a checkbox in the editor where we can enable or disable the debug lines while our game is running. Okay, in our wheels script, add a new if condition to check if our debug is enabled. If so, we want to draw the lines. Use the function draw arrow line from the debug draw 3D and pass the initial position and end position, that in this case is just the position plus a vector with our force, and also the color, the size of the arrow, and the absolute size. Set it to true, and let's run the game. Enable the debug flag, and you can see we have our debug errors indicating the force being applied to our suspension. Let's run one more time so we can see it better. To get rid of those error messages, let's reload the project. Okay, now that we have our suspension lines, let's also add the raycast lines so we can see where our raycasts are colliding with objects, in our case with the ground. This time though, we're gonna call the function drawLineHeatOffset. The parameters are pretty similar. Just change the y value of the end vector, in this case -1, since we want it pointing downwards. Let's choose a different color like red, and also we need to pass the distance. Let's see what we got. As you can see, now we have also the raycasts with collision point indication. Feel free to add more debug drawings to your car. For example, if we want to see where is located this point variable that we use, just call the function drawSphere, passing it as a parameter. Now we can see where our force is being applied. Using those debug tools are very important because they give us valuable information about the behavior of our car that can help us to find bugs much faster. Okay, now we can comment this line, we don't need it for now. And let's move on to the implementation of our acceleration behavior. The first thing we need to do is to add new inputs to our game. So let's create a new input here called accelerate and another one called reverse. And let's use the keys W for accelerate, and S for reverse. Now let's go back to our car script and add a new export variable called engine power of type float. This is an arbitrary value that we will inform later, and also a variable called axle input. Now override the process function and set the axle input with the value of input.getAxis, passing as parameters the actions we've just created. Back to our wheels script. Let's refactor this code to make it more organized. Let's separate the suspension in its own function. It will receive as parameter delta and the collision point. Now let's call it passing those parameters. First, we need to get the collision point. And now just call the function. Inside the suspension function, replace the calls to get collision point with the variable we are passing as parameter. Save it and let's test the game. Okay, it's working just like before. Now let's create a new function responsible for handling our acceleration. In this function, we don't need delta, just pass the collision point. Now create the function receiving the parameter. Now let's define the direction we want to apply our force. In this case, we're gonna use the global basis z-axis. Since we want to move forward, we need to negate the value. Calculate the torque multiplying the axle input times the engine power. We need the points to apply our force, so let's just copy the same variable from here and paste it here. And finally, apply the force, passing the value times the direction and the position. Let's run the game. Press S, W. It seems we are just controlling our camera. Actually, we have a problem that our camera is using the same inputs we defined. So let's just edit the script here and change those keys. Okay, let's test now. This is still not working. It makes sense since we haven't defined the engine power yet. So let's do that. Go to the 3D view, select the car, and set a random value, for example 1, and let's try again. Press W and S, W, and our car is moving. Also, as you can see, our suspension debug lines are giving us information about what wheels are more compressed or not. Now let's try with a different value, for example 5. Oops, it seems a little strong. Since our car is very light, let's decrease a little to 2. Okay, great. We can accelerate and reverse our car. We can also add debug lines to see our acceleration. Just like before, add a condition to check if our debug is enabled, and again call the draw arrow line function. Pass the point as the initial location, and the end location will be the point plus our calculated force. Let's choose a blue color this time. Pass the size, and if it is absolute size. Let's see how it looks. Great. Now we can see the direction we are accelerating our car. But as you can see, our four wheels are applying the force, but I want only the ones at the back to do it. Let's create a new export variable called isFrontWheel that will be responsible for identifying the front wheels of our car. Inside the acceleration function, before applying the force, let's check if this wheel is at the front. If so, we return without doing anything. Now go to the car scene and select the front wheels and check the box is front wheel for both. Let's run our game again. Accelerate the car, and now only the back wheels are responsible for accelerating our car. So that's it for this tutorial. Thank you for watching, and until next time.